Hello everyone. Welcome to this series on computer applications. This series is specially designed for students following the ICSE curriculum prescribed by the CISCE Council, New Delhi. We'll be covering key topics and concepts as outlined in the official syllabus, explained in a simple, practical, and student-friendly way. Selection sort process. I want to arrange some children who are standing in a line. I want to arrange the line according to height. So there are five children. The five children are actually standing at position 0, 1, 2, and 3, and 4. And the heights of the children are visible to you. Okay, I've not given numbers here. I've just shown them as heights. Okay, I am standing beside the first child, child number 0. And starting from child number 0, I try to figure out from the beginning till the end which child is the shortest. So I can see from here that child number 3 is the shortest. So what do? I swap their positions. So I was on position number 0, and where I found it to be the shortest is position number 3. So I started from here at 0. I write down 3 as the position where I found it to be the shortest, minimum value. So what do? We swap position of number 0 and 3. So position number 0 and 3 are the two basically the ones which we are actually concerned about. So we swap their positions. So position 0 goes to 3 and position 3 comes to 0. Now you can see for yourself that the shortest child has now come to the beginning of the row. Okay. What do we do next? We move forward. I move forward to position number 1 now. Okay, I also here move it to position number 1. So starting from position number 1, which is the shortest child, I figure out that number 2 is the shortest child. This is the shortest child. So I write down number 2 here. So if 1 is where I started from, 2 is where I found it to be the minimum value. So I swap their values. Okay, swap their positions. And the positions are 1 and 2, so I swap them. So I bring 1 here and bring 2 here. So both of them have now changed their positions. Again, I move forward from 1 to 2. That means I go and stand beside child number 2. And from here, I try to figure out from here till the end of the row, which is the shortest child. I find that 2 is the shortest child. Now, if 2 is the shortest child, do I need to do anything at all? No. Why? Because I don't need to swap because the person is the shortest child at the moment. So if that means where I started from and where the minimum value was found, if they are the same positions, I don't need to worry about swapping them. So what do we do next? Next we go to position number 3. So that means I go to position number 3. I stand beside child number 3. Okay, and try to figure out from starting from 3 till the end where is the shortest child. The shortest child is on position number 4. So if the shortest child is on position number 4, so 3 is where we started from. We swap them. We swap position 3 and 4. 3 comes there, 4 goes here. Okay, alright. Now tell me, do I need to go and stand beside position number 4 and figure out where is the shortest, or can I finish the process now? I can finish the process now because there is no need to come here because this is the tallest child, so I can remove this process. I don't need this process at all. So that means basically I would basically start from position number 0, go up to position number 3, and from every position I figure out which is the shortest child. I swap their positions. I'll take another example. Now the values are different, but again we'll start off. I'm on position number 0. I'm standing beside the child number 0. And starting from position number 0, I figure out which is the smallest. Smallest is on position number 2. Let me write position number 2 here. So 0 and 2. So because 0 and 2 are different numbers, 0 and 2 are different children, I swap their positions. So let me swap their positions. Position number 2 comes here, 0 comes here. Now I go and stand beside child number 1. I go and stand beside child number 1. And from position number 1, I figure out where is the shortest child. The shortest child is on position number 2. Let me write position 2 here. I started from 1 and ended up at 2. So I swap position number 1 and 2. Let me swap their positions. The positions are swapped. What next? I go and stand beside child number 2. Go and stand beside child number 2. From here, which is the shortest child? Shortest child is actually on 4. So what do? I swap position number 2 and 4. So 2 goes there, 4 comes here. So they have been swapped. Now starting from, I go and stand beside number 3 now, and starting from 3, where is the shortest child? It is on 3. I don't need to do anything. Why? Because this is the shortest child. Okay, I don't need to go to position number 4 and do any search. Okay, that is not at all. So you can see that by the end of this process, you can see all the children are now in arranged according to their heights. Let us see the same process as numbers now. Okay, I have an array containing numbers, and these are the values containing, these are the numbers, and these are the positions. And my current position is position number 0, so I'm beside position number 0. It is here 0 also. And starting from 0, going out to up to the end, in this particular range, we need to find where is the smallest value. And the smallest value is actually on position number 3. So let me write position number 3 here. And you can see I need to swap position number 0 and 3. So the value 8 comes here, uh, goes from here, and 8 comes here. So that means number 8 and 1 are actually exchanged. I change my current position to 1. So starting from 1, going to the end, where is the smallest value? The smallest value is on position number 4. So let me write a 4 here. So we will be swapping position number 1 and 4. So 1 is here, 4 is here. So 2 comes here, 4 comes here. Till this moment, we have come to position number 1, and you can see that position number 1 or 2 are already arranged in ascending order. Next is position number 2. So starting from 2 till 4, where is the smallest value? The smallest value is now on 4 also. Same thing. So position number 2 and 4 needs to be swapped. I put 4 here and put 5 here. Again, I move position to position number 3. Here also to 3. Starting from 3 going on to 4. Where is the smallest value? It is again on 4. So I swap positions 3 and 4. 5 comes here. 8 comes here. Okay, the process is over. I don't need to search from 4 at all. Now you can see that this array is now arranged. Okay, let us start planning for our program now. When we were looking at the logic, we saw that the positions where we used to start from were actually 0, 1, 2, and 3, and these were the 4 possible values. Okay, so these are the 4 possible values of x, which is going to be our outer loop. Now we are looking for the position where the smallest value is existing. So naturally we'll have to use a loop for it. Where is that loop going to start from? It is always going to start from wherever my current position is. If I am on position number 0, it will start from 0 and go up to the end. If I am on position 1, it will start from 1, go up to the end. If I am on position number 2, it is going to start with 2 and go up to the end. Now you can see the inner loop. I have decided that I am going to use the variable y for it. For the outer loop, I am going to use the variable x for it. So what is the range of x? X is going to be 0 to 3. And if x is going to be 0 to 3, you can see from over here that we have actually used 0 to 3. So when I say 0 to less than m dot length minus 1, so what is the value of m dot length? M dot length is 5. 5 minus 1 is 4. If I write less than 4, it is going to go up to 3 only. So my outer loop is decided. It will go only up to from 0 to 3. And it is 0 to less than m dot length minus 1. So that is clear now. What about the inner loop? Inner loop is always going to start from wherever the x position is. So it will always start, because see, it is always ending at 4. It is always ending at 4. Okay. But it is starting from whatever is the position of x. So here also we can need to decide, it is always starting at x, but it is ending at the last position. So how do we write that? We write this way. We say y is equal to x. It is starting from x. Y is less than less than m dot length. So y is less than m dot length. This means it will go up to the last element and y plus plus. So the two loops we had decided, and it is going to be a nested loop. We had decided that also. How do we find the lowest position? How do we find the lowest position is wherever we want to start from. If I want to start from 0, I'll say int low is equal to m0 and position is equal to 0. But now I'm going to start with x. It is always going to be int low is equal to mx and pos is equal to x. Why? Because I'm going to start from the xth position, I'll store the xth position's value into a variable called low and x into pos. And pos is the variable which is actually finally going to store the position of the smallest value. This loop is basically going to decide on wherever is the smallest value. So how are we going to do it? We take a loop y is equal to x, y is less than m dot length. We have done that. We know that. And in if any of these m's positions, that means my, that means whatever it is, if it is starting with 0, for m0, if it is found to be less than low, then low will change its value. And which value will it be? It will be my, because my was found to be low, less than low. So low gets the value of my and pos gets the value of y. Now pos knows the position is y now, because where did we take the value from? The position of y. So once this loop finishes, and will know what is the position of the smallest element, that is pos. And x, what is x? X is where we started from. X is where we started from. And if they are not equal, we also know this. They are not supposed to be, if it is the same position, that is the smallest element as on the same position as x, I don't need to worry about all this. Okay, so if they are not the same, what do? We create a temporary variable and swap those positions. Which positions? The x position and the pos position. Okay, this is a simple case. X has the values of 0, 1, 2 and 3. Here we initialize those values. This loop is basically used to find out the lowest value, the position of the lowest value. This if statement, if, is basically used to decide if they are not the same positions, then we swap the position of x and pos. The program is going to look like this. We will take an array containing some values. Let me just reduce these number of values. Okay, let us take 5 only. We display before sorting, okay, and we display the array before sorting. So that should be very clear, no problem there. And we display a line in between, okay. During sorting, now we start the sorting process here. Now you know that the outer loop is going to go from 0 to less than m dot length minus 1. So that should be very, very clear to you. Int low is equal to so and so, pos is equal to so and so. We have already done that. This loop is basically used to decide what is the position of the smallest value, and x now is the starting position. Pos is where the smallest value is. If both the positions are not the same, then we use a temp variable to swap the values. And in the loop, actually, I have displayed this. I've not used x and y as the variables for the for loop. Okay, I've used another one. Okay, so you also should not use the same variable used for the for loops of which are basically used for sorting. Okay, don't use x and y. Use anything else. This will not be required by you in your actual program, but I am displaying the values inside the loop once one swap has happened. So if one swap has happened, this is where I'll be. So this is where actually I am displaying the array. Okay. So I will also see how the swapping is happening. Okay. And after everything happens, it basically displays the array after the sorting has actually happened. All right, let us run this program. Okay, now you can see that the initials before the sorting, the position was like this. It started off with 101, 27, 66, 55, 43. Now, in the first in the first loop, you will see that we are starting with 101 and 27 is the position where the smallest element is. And you know that 101 and 27 are going to be swapped. So this is what has happened here. 27 and 101 have been swapped. What do you think will happen next? I'm going to start with 101, and from 101, which is the smallest value is 43, and we will now swap 101, which actually goes to 43's position, and 43 which actually goes to 101's position. The next is 66. We are starting with 66, which where is the smallest value? The smallest value is at 55. So we swap the 55 and 66. Done. After this 66, we start from 66. Now this is the smallest value. It will not be swapped. It will remain like this. And at the end, we display the array, and it is a sorted array. I am going to add some more numbers here, and let's see how things happen. So if I am using 23, comma, 99, comma, let's make it 123. All right. Compile it and run it. See what is happening? We start from 123. Where is the smallest value? Is at 27. So 27 and 123, they exchange places. Next time we start from 99. Where is the smallest value? The smallest value is 43. So 43 and 99, they exchange places. Next time we start with 101. From 101, 55 is the smallest number. So 55 and 101, they exchange their places. Next 123. From 123, 66 is the smallest. So 66 and 123, they exchange places. From 123 again, 99 is the smallest, so 99 and 123, they exchange places. And starting from 101, 101 is the smallest number and it is the same location, so no swapping happens. Finally, this is the sorted array. If you found this video helpful, please like, subscribe and share it with your fellow makers and learners. Got questions or ideas? Drop them in the comments. I will reply.